Hello and welcome to another video. In this video we're going to be working on remove zero sum consecutive nodes from a linked list. And in the problem you're given the head of a linked list and you want to delete consecutive elements that sum up to zero until there's no such sequences. After doing so, return the head of the linked list. You may return the answer in any order. Note in the examples below, all sequences are serializations of lists. So basically they give you an array, but it's really a linked list. So in the first example, you can delete this for sure because this sums up to 0, and then you get either 1, 2, 1 or 3, 1. You can also get 3, 1 by deleting this. So as long as you get rid of consecutive sequences, it doesn't really matter. Yeah. And in the second example, you can delete this and you get 1, 2, 4. And in the third example, you can delete this and this together. So this whole thing can be deleted right here, and then you just get the 1. So the main thing to know for deleting, like, you're basically looking for subarrays here that add up to 0. And if you've done problems with prefix sums before, this is basically like the perfect use case for it. So prefix sums, if you do prefix sums, if you get the same prefix sum twice, that means the subarray between those two sums has to add up to 0. So if we take a look at this, here's like our array and here's the prefix sum on the bottom. So if there are two numbers that are the same, like the prefix sum is the cumulative sum you've gotten so far. So if you have a sum of 3 and you have a sum of 3 later on, how do you get to that? It's because all the operations you added and subtracted end up canceling out and giving you the same number. So if we take a look, if there's a 3 and a 3, that means that everything from the first 3 to the second 3, not counting the first 3, has to add up to 0. So this has to add up to 0. Also here, there's a 1 and a 1. That means this whole section has to add up to 0 because this whole section has to add up to 0. Then you would get 1 plus 0 equals 1. And let's take a look at that. So this 3 plus 3 is 0. 2 plus 4 is 6. Plus 6 is 12. Minus 12 is 0. And so you can do a prefix sum and like some linked list stuff, but instead what I'm going to do is I'm going to use I'm just going to take an array of the values, because that way I can pop values off the end whenever I hit like the same prefix sum that I can't do with a linked list because I can't go back in a linked list. So we're just going to like go through, like, imagine this is our starting linked list. We'll make an array of values, and instead of prefix sum, we'll just maintain a current sum. And anytime we hit a current sum we've seen before, we'll just start deleting items until we hit to the other sum. And because we're basically looking, anytime we hit a duplicate, we're just going to keep deleting until we go back to our other thing. We can just use a set for that. So we'll have a set of all the sums we've encountered so far, and we can build our array of items. So let's walk through what that's going to look like. Let's use, I guess we can use like an array of items we build, and then we'll just like pop things as we go. Or actually, we can just pop things from the original array as we go, and this is going to be the new one that we're building. And so we'll have a set on the bottom, and we need to keep track of a cumulative total to know our like prefix sum. So let's walk through how that's going to go. And also for a prefix sum, if you're looking for arrays of sum 0, you do need to put 0 into your original prefix sum, because let's say this adds up to 0. You're going to be like, oh, I have a 0 here. Do I have a 0 before? And you won't unless you have a 0 originally. So we'll add the 0 into our set, and we'll have a total with a 0. And then we can just traverse here. So we're going to add the 1 to our total. So our total is going to be 1. And I'll just keep crossing it out, putting new numbers to make it a little bit faster. And is our total in our seen sums? No, it's not. So we'll just add it in. Then we go to the next number, so we add a 2. So we will, oops. Actually, let me do it this way. This will be easier. So our total is 3, and we don't have it, so we'll add it in. Then we go to the next one, and now our total is 6, and we don't have it, so we'll add it in. Then we go to the next one, and our total is 3 again, right, when we subtract. And now we do have the 3. So if we do have the 3, that means we need to delete until we go back to our previous spot where we had a 3. And that makes sense because this is the previous spot where we had a 3. So if we just delete numbers till we hit there, we'll get rid of everything that adds up to 0, which is this. And it doesn't really matter how you delete. So like I think we originally said that this whole thing adds up to 0, but it's fine to like get rid of a chunk first and then another chunk. Because if a whole array adds up to 0, if you get rid of part of it, which adds up to 0, the rest of it still has to add up to 0, right? Like if this is 0 and this whole thing is 0, that means the rest of it also has to be 0. So it doesn't really matter that you're deleting as you go. So as soon as we hit a 0, we'll just delete right away. So basically we're getting rid of this section here. and we need to update the sum as we do. So we need to get rid of this number here, so we can toss it, and then we update our sum. So now our sum is 6, and it's still not 3. And as we delete numbers, we're gonna delete them from the set as well. So our sum is 6, which is not 3, so we need to keep deleting. So we'll delete this 6 from the set, and we'll delete this block. And now our sum is 3. So that means we've deleted everything we needed to go to our previous number. Then we go to our next number, and we're not going to be traversing our numbers, we're going to be traversing our linked list. So this will be more like we're going to be building this as we go, and then just traversing down the nodes of the linked list. So here, the total is going to be 7. Have we seen it before? No, so we'll add it in. Then we go to the next one, the total is 12. Have we seen it before? No, so we'll add it in. Then the total is 13. So haven't seen it before, and we will add it in. Then the total is 4. So total is 4. Now we have seen it. Actually, no, we haven't seen it before, and we haven't seen it before, so we will add it in. Then the total is 1, and now we have seen it before. So now we're saying, okay, we have to delete until we hit our total of 1 again. So we're going to delete this, update our total. We deleted -3, so now our total is 4. Is 4 1? No, it's not, so we're going to delete 4. Delete 4. I'll try to delete 4. Okay, there we go. And so our total is 4. We delete it, and then we have to delete this number because our total isn't 1. So now our total is 13. Is that 1? No, it's not, so we'll delete 13. Then we delete this block, and we just deleted 1, so now our total is 12. Is 12 1? No, it's not, so we'll delete again. Then we need to get rid of this item because we only have 12, and we need to keep going. So delete this. Now we have 7. Is 7 1? No, it's not, so we need to delete the 7. Then because we still don't have what we want, we need to delete this block. Now our total is 3. Is 3 1? No, it's not, so we delete the 3, and we delete this block, and now our total becomes 1. And now we're good. We have a matching total. So everything we deleted, like if we go back, everything we deleted ends up adding to 0. So we deleted all these numbers right here. So 2, 4, 5, so this is 11, 12, and this is 12 as well. So all these 6 numbers add up to 0, which is what we wanted. So we delete all this. Like I said, this arrow isn't super accurate. It's just kind of showing for the picture. This arrow will be really going through our linked list, and we're just going to keep deleting the last number in our array. So we'll just keep popping and then changing the total. So now we go to our last number. So the total, and this should have been 1, not 3. The total here is 6. We add it in because we don't have it yet. And now finally our array is only 2 numbers. So we'll just keep popping off the end. Our array will be like a stack. And then once we have this array, that's all our valid numbers, then we can just build a linked list out of it. So we'll just start from the beginning and just build a linked list. And then we will return this here. And this will work for all this other stuff. So you can like move all your nodes, but because you need to have space, like normally in linked list problems are constant space. In this one, you need to have space no matter what, because you need to have like a prefix sum or some kind of thing. So because you need to have space no matter what, I'd rather just get the numbers, modify the numbers, and then make a linked list instead of like dealing with all the pointers. So let's take a look at the code. So here it is. So we have our nums that we're going to be building as we go. Our current will be at the head, and we'll just keep going, and we'll just go 1 node at a time. And then this is our scene, which is like our sums we've seen, and we put in a 0. And we have our current total. Then while we have nodes, we need to add the current value. We need to increment the total. And if we've seen this total before, we are going to get rid of the node. So we're going to update the total, get rid of the node, and decrease the total. And we're going to save this value in this current total that we're looking for is current total. So if we go back in the picture, for example, like here, basically what we do is if we have a number we've seen before, go back a little bit. Actually, I think it's right here. So here, our total was 1. And we're going to be like, okay, we've seen it before, so let's just save this value and then keep updating the total, but we need to make sure that the total equals the total we saved earlier. So as we keep updating this total, we're looking for 1, so we save that in this current total. So maybe this is not the best name, it's kind of backwards. Current total is actually the total, and then we're actually decrementing the total. And then once the total is the current total, that means we've like deleted enough nodes. So essentially what we do is, while they're not equal, just keep removing prefix sums from your set and keep deleting nodes. So decrement the total, delete the node, remove it from the set. Otherwise, if we haven't seen this sum before, just add it to the set, and we don't need to delete anything from our numbers. And we just go to the next node, so we just, like, our current literally just traverses the linked list and builds up our actual stack. And anytime we've seen a prefix sum, we just keep deleting until we go back to the previous location we've seen it at. It's kind of like a sliding window thing where you're trying to do like no repeating characters or something. You have a set of characters, kind of similar scenario there. And finally, you just have an array of numbers, and then you just build an array of numbers from a linked list. So I just made a dummy node. I made the current equal to that, go through every single number, build a node, make its next pointer the next node, and so on. So that part should be pretty straightforward. Like, given an array of numbers, build a linked list. And this does work. And I do prefer this over like actually changing the pointer in a linked list, because like, what's the point if I need space anyway? If you don't, I would say like 90 to 95% of linked list problems are O of 1. So then obviously you would just deal with the pointers, but here you need O of n space, so like you might as well use an array. And so for the time here, this will be O of n, because we're basically like traversing our linked list once, and then the most nodes we can ever delete from the array we make is also O of n, right? Like, as we're building this array, we can only delete nodes one time, so that's O of n. And then to build out like our linked list for the very end is also O of n, right? Given an array, build out a linked list, that's O of n. Then space. So we can only have for this scene set, obviously for n nodes, you can only have n different sums, so that's O of n. For the array of numbers, the number of numbers you're going to have is equal to the number of nodes, worst case, that's also O of n. So this is just basically O of n, O of n. Yeah, but I think this can be it for this one. So definitely one of the a little bit trickier linked list problems, because you're basically just doing, this is basically just given an array of numbers, remove all arrays that add up to 0, but in a linked list. So you're basically not using almost any linked list properties or anything. It's just basically use an array. And yeah, so if you know how to work with prefix sums, and if you do know that that concept that when you hit two prefix sums that are the same, that adds up to a 0, that whole array between those is 0, then this is pretty straightforward. And that's going to be all for this one. If you did like this video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.